is going to be on the Introduction to Organic Chemistry. It's part of the Unit 1 spec, but you may also be watching this if you're in A2 and you're doing your Unit 4 exam, because it comes right back up on the nomenclature and isomerism. And in this video I'm going to discuss the formulae, naming and isomerism. Okay, so the definitions for the formulae, starting with the molecular formula, is it's the actual number of atoms of each element present in a compound. The empirical formula is the simplest whole number ratio of atoms of each element present in a compound. A structural formula shows all of the atoms in a compound carbon by carbon. And a displayed formula shows all of the atoms in a compound, including all of the bonds between them. So what I'll hopefully do now is, if my editing goes well, is I'll include a picture on the screen that will basically just show you a structural formula and a displayed formula. Okay, so now moving on to naming. Alkenes, we use the suffix -ene. We have to number the position of the alkenes, and this is because they could have been on, say for instance, position 1 or position 2 in the chain. And an example of this is but-2-ene, but you could easily have had but-1-ene, and I'll show you a picture of this hopefully on the screen right about now. In terms of alcohols, we use the suffix -ol for these, and again numbering is necessary to show the position, and it's exactly the same reason as I said for the alkenes. It could be on a different position, which would make it a position isomer, which I'll come on to later. And the example I've got here is pentan 2-ol, and there should be an example on the screen right about now. Okay, so moving on now to a bit more simple than what I've just said. When we're discussing alkanes, we normally have to look at the number of carbons in the chain to decide what the base for the naming will be. We do this by looking at the chain length. For instance, if there's 1 carbon, it's called methane, isn't it? So we use the prefix meth. If the chain length is 2, we use the prefix eth. 3 is prop, 4 is but, 5 is pent, and 6 is hex. It does go on infinitely, but for the AQA A-level specification, you only need to know from 1 to 6. Finally then, naming haloalkanes. If there's a halogen in your alkane, haloalkane, you name it efficiently. So if you've got a fluorine, you name it with the prefix fluoro. If it's chlorine, you use chloro. Bromine is bromo, and iodine is iodo. And just something to note, if you've got 2 fluorines in your haloalkane, so for instance you've got a CH2F2, then you'll have to name this as being difluoroethane. Okay, so moving on now to the isomers. For the Unit 1, you will need to know about the structural isomers, and the definition of these is they have the same molecular formula but different structural formula. There are 3 types of these structural formulas. One of them is the chain isomer, and this is where they have the same molecular formula but different chain arrangements. And make sure you remember these definitions because they often come up for Unit 1. And an example of this is butane. So the structural formula of this is CH3, CH2, CH2, CH3, and this is also a chain isomer of methyl propane. So as you can see, it's got a different chain. The chain now is only 3, but it's still got the methyl, and the structural formula of this is CH3, CH, bracket CH3, close bracket CH3. If you want to see that this has the same molecular formula, well, here we go. Let's count. So it's got 1 carbon, 2 carbon, 3 carbon, 4 carbon. The methyl propane, 1, 2, 3, 4. Hydrogens, we've got 3, 5, 7, 10. Here we've got 3, 4, 7, 10. There you go. We've got 4 carbons and 10 hydrogens. on this side, 4 carbons and 10 hydrogens. Okay, so then the next type of isomer is the position isomer, and these have the same molecular formula but different functional group positions, and this is the reason we have to number our functional groups, such as the alkenes and the alcohols. And this is because we can have one chlorobutane, but easily we can have a position isomer of this as being 2 chlorobutane, and the chemical properties of these will be different, so that's why we have to number them. Finally then, we have a functional group isomer, and these have the same molecular formula but different functional group, and the only example for this you need to know is alkenes are a functional group isomer of cyclic alkanes and vice versa. So cyclic alkanes are the only functional group isomer of alkenes. And if you want to see why, say for example if we had butene, make that but-1-ene, and I'm just going to do sticks for my hydrogens, and I've already done that wrong. Well, the only functional group isomer of this where we can change the functional group is by making this cyclic. As you can see, we'll have 1 hydrogen, 2, 4, 6, 8 hydrogens there. 1, 2, 3, 4, 5, 6, 7, 8, and we've got the 4 carbons and the 4 carbons. So as you can see, they've got the same molecular formula, but they have different functional groups. Because here there's a double bond, here there is no double bond. Okay, so hopefully that helps with the introduction to organic chemistry. Goodbye.